Thanks for that introduction, and thank you all for being here. It is my goal and my sincere hope that something I say today is going to positively impact the lives of your students. Whether you're just thinking about adding more research experiences to your class, modifying a lab you already offer, or maybe taking the plunge and adding a lab component to your intro class. If you are, that's great, because I believe our introductory course should not only provide firsthand experience with the science of psychology, but a first-rate introduction to the general philosophy and practice of natural science. Now, in fact, limiting myself to 8 reasons was really challenging. And as you'll see, I will be sneaking in a few others, but I'm aiming for 30 minutes. So briefly, before I get into the chosen reasons, I want to let you know where I and this passion of mine came from. I earned a Bachelor of Science degree in psychology and education in the late 1980s. I wanted to teach high school psychology in the worst way, but there was no certification for that at the time. So I got certified to teach biology, another favorite subject of mine, especially the neuroscience end of it. Then I got married and I had 3 wonderful kids, and I went back to school in the 1990s for a master's in biology, studying the neuroscience of learning. I taught psychology and I did faculty development work for 8 years at a local community college. And then I finished a PhD in biology, again, focusing on neuroscience. Then as I began looking for tenure track faculty positions, teaching psychology and/or neuroscience, this place happened. Now, in my junior and senior year at SUNY Oswego, I got to lead a weekly recitation for intro psych as a TA. And I often said that this was one of the best academic experiences of my life. But I also said many times that recitations are great, but I really thought that intro psych should have a lab, like intro bio, like other intro science courses. So fast forward 20 years, it's 2006, and I'm finishing my PhD, and I'm looking for this tenure track job. And I see this ad for a position in the psychology department at Lafayette College. Now, actually, to be more accurate, my husband was the one who saw the ad. And he's like, hey, look at this. Lafayette offers intro psych with a lab. They need someone to coordinate it. And I'm like, what? Are you kidding me? And he's like, no, it's for real. So of course I applied. I was so excited by the chance to do this that I just didn't care whether it was tenure track or not. I figured it would be like the perfect postdoc. I could work on it for a year or 2, maybe 3, develop the lab course into the kind of science lab that I had always envisioned, and then seek a tenure track job after that. But time went by, and I was really honestly having the time of my life, developing, coordinating, and teaching intro psych labs. It was my calling. Occasionally I took a break and I taught other courses, but intro was my baby. And like most babies, it took way longer than 3 years to develop. But that was a good thing, because this is what came out of it. And the first edition was in 2015, and in 2020, I wrote a second edition. Now, you don't have to be a webinar groupie to know that your presenter probably has a book associated with the presentation. That admission usually comes at the end, but in this case, knowing about the book might ease some of your concerns about whether what I'm talking about is actually doable. And this slide represents the fact that, yes, it is doable. This is the building where I did it for 13 years, and this is the book that includes the tools I used. And I will mention some of those tools during this talk as ways of meeting challenges, but the book is not the main idea here. And with a little imagination and decent time investment, you can teach intro with a lab even without this book. Now you might be thinking, hold on, wait a second. Just because we can do something does not always mean we should, right? We all know, Jeff Goldblum can attest to that. Things can go wrong, and it can be scary, and it might even be messy at first. Not this messy, of course, but yes, we should be teaching intro with a lab. I'm going to focus on why, the logic, the benefits in my experience, and where actual data are available, I will share them. So if teaching intro with a lab is something that you've been thinking about, I hope to give you good reasons to move forward with those thoughts. And maybe I can provide some information that will help convince reluctant peers or administrators to support it as well. So a quick overview of the reasons, just so you'll have some idea where we're heading. First, psychology is a science, but it's more than just a science. I'm going to defend that statement in a minute. Second, we're going to visit the recommendations of the most recent introductory psychology initiative from the American Psychological Association. Third, I will present some research on perceptions of psychology as a science and whether those perceptions relate to the teaching method used. Fourth, I'm going to discuss the costs of running a lab. The fifth reason is about student development. And the asterisk is to remind me to say that this is actually a threefer. There are 3 reasons packed into this one little box. Sixth, I want to talk about how the lab influences preparation for more advanced courses. Seventh, the potential impact on retention, and I'm referring to graduation rates here, not memory performance, though personally I do remember some lab experiences more than lectures. Lastly, I want to make the case that in terms of resources, you really can hit the ground running with this endeavor. And because I am slightly OCD, I cannot leave this rectangle unfinished, so I'm going to throw in a bonus reason. We'll call it the mystery reason for now. Okay, so reason 1. Psychology is a science, but it is much more than just a science. It is embedded in the scientific literature. Researchers in other fields frequently turn to psychology for information and vice versa. This is a cluster map of the areas of research covered in over 7,000 science journals. Every small circle is a journal, and its proximity to other journals shows how many times the 2 journals cite each other. Large fonts indicate that the topic is a hub, that is, an area of research with one of the top 7 frequencies of co-citations with journals from other disciplines. And here's psychology, one of the hubs. But it's more than that. Subdisciplines of psychology also appear 2 more times among the second tier, also frequently co-cited areas of psychology, of science. On the left, we have this area of psychology that I believe represents applied educational clinical psychology, and to the right, experimental psychology. So it's a hub plus 2. So in essay 1.1, which is the first essay of the book, I include this figure as part of the evidence that psychology should be thought of as a science. But I do this within the context of arguments about why it should not. Because one important goal of that essay is to help students begin to understand that there are no absolutes. There's logic and there's evidence, even when it comes down to such a basic question as how we define our field of study. I'm going to come back to this later as one of the benefits of having students engage in scientific practice. But moving on, our status as a hub is not the only reason that I say psychology is more than just a science. It's also a hook science. It's a science about her, that enthusiastic learner in the front row. It's also about this guy and this girl. And yes, even this guy, maybe sitting in the back row, who knows? Students can look at psychology and say, it's about us. It's the science of people. Of course, we study non-human animals too, but for many college students, it's the human aspect that makes psychology so interesting. About 1.5 million students take intro psych every year in the United States. It's the second most popular course, partly because it often fills core or gen ed requirements, but at Lafayette, it also fills the natural science lab requirement. So about 80% of our students are not psych majors, and many of them will never take another science course. Think about that, 1.5 million. That's a lot of students. And by not including a lab, I believe we're missing a monumental opportunity, maybe even an obligation to improve science literacy for so many more college graduates. Imagine how many of these students need just a little experience doing research to discover that they actually like science. I've had so many students in my labs over the years say that they never thought science was interesting. They thought they were bad at it. But Psyclab taught them that science is not just a bunch of facts, it's a way of thinking. And they actually liked that way of thinking. They just never knew it. So reason number 2, the APA IPI SLOs. I said it. I really thought I was going to stumble over those acronyms. Sorry. Anyway, this is the most recent version of the Intro Psych Learning Objectives from APA. It's dated October 2021. Notice that scientific thinking is not just a bullet point. It has its own bullet point, and teaching a lab hits all of them. It has 4 of them. So 2.1, describe the advantages and limitations of research strategies. By meeting 3 hours a week, just like other sciences, students can read about and do each type of research: exploratory, descriptive, correlational, experimental, and quasi-experimental. And a good portion of the studies in our lab are not just canned projects. In some cases, they can decide on the variables and write the operational definitions and the hypotheses themselves. So sometimes the outcomes are uncertain, and I think that's important, but they also get immersive practical experience with what they can and cannot conclude from each type of research strategy. So there's that. Then there's 2.2, evaluate, design, or conduct psychological research. They can do all three. 2.3, draw logical and objective conclusions about behavior and mental processes from empirical evidence. Discussions and lab records assure this. Each research project in our lab and in the book has a lab record worksheet that follows scientific standards for note-taking. So in our labs, students completed these independently as homework and then peer-reviewed and discussed their answers in small groups in the next lab. So they discussed the logic of their work and their conclusions a lot. 2.4, examine how psychological science can be used to counter unsubstantiated statements or opinions or beliefs. And yes, an example, one of the research projects they can do is a test of attention while doing an online driving test. Now, it's not about texting because most people agree that texting while driving is a very bad idea. But if you ask for a show of hands in class, just about every student is going to raise their hand and go, yeah, I talk on the phone while driving. And they firmly believe it has no impact on their attention to the road. So we test that belief with a repeated measures counterbalanced experiment with 3 driving conditions: control, word repetition, and conversation. And 9.5 times out of 10, their findings suggest that it's a bad idea to have an intellectually demanding conversation while driving. And in the rare cases where the effect is not significant, we have had the opportunity to show them all the times that it was and to discuss the probabilistic nature of hypothesis testing. So all of these IPI objectives are addressed in a lab, plus one of the content objectives up here, 1.2, interpret research findings related to psychological concepts. Also key themes: A, psychological science relies on data, on empirical evidence, and adapts as new data develop. And G, let's move up a little bit so we can see it right there. Ethical principles guide psychology research and practice. That's 7 out of 14 learning objectives. Is there any other single thing that you can do in an intro course without completely overhauling your lectures that's going to accomplish all that? I don't know. I don't think so. Now, I feel like I'm maybe sweeping a clean floor here, but forgive me. This graphic, I think, from the IPI also illustrates my point in a powerful way. Notice how these integrative themes, these pillars of understanding in our discipline, all sit upon a single foundation. Without a good understanding of research methods, that foundation falls apart. And in general, content doesn't stay with students as long as experience. And I believe that the experiences they have, rather than being simple demos of optical illusions and operant conditioning, should provide the foundation for the course. Lab experiences should immerse students in the same spirit of inquiry that defines a scientific community. Because the science of psychology doesn't just talk about the content in these pillars. We do the research that builds them. By bringing students into the fold and teaching them how to do research, they might begin to see themselves as information generators rather than information sponges, which sets them on a much better path for their future and ours. And yet only about 6% of schools in the US require a lab with intro. Now, I put a white block in front of the foundation on this graphic and set it to 6% transparency. If that's how hard we're trying to get this message through, we're not trying hard enough. I mean, yes, maybe this is a little overstated. I'm not saying we can't or we don't teach any research methods in lecture. We do our best with the time we have, and I know that. But one chapter about research methods at the beginning of most textbooks, even with occasional references to research methods throughout the book, is just information. It's not experience. Reason 3. Respected professionals in psychology have been saying for years that adding research experiences to intro psych would improve perceptions that psychology is a science. I mean, it makes perfect sense, right? Doing science in psych should increase perceptions that psych is a science, right? Surprisingly, evidence for this idea is mixed. Maybe because the operational definitions of doing science and the perceptions of psych as a science might lack some external validity. For example, what does doing science mean to most students? Is it this or is it this? Now, given the choice, I think most first-year students would point to the bubbles in the Erlenmeyer flask and say, yeah, that's the one doing science. Just recently in 2021, Branch and Dubois compared 3 groups of students taking intro psych. One group had an additional 50 minutes per week of lab. Another had the same amount of time devoted to a behavior modification experience. And a third group had a traditional recitation. To measure their perception of psychology as a science, students completed the PAS, Psychology as Science scale, both before and after the course. Now, before I tell you the results, I hope you're sitting down, because overall, PAS scores decreased. Ouch. The lab group was no exception, which is doubly painful to me, but the idea that just taking intro psych could decrease perceptions of psychology as a science probably doesn't sit well with you, or you wouldn't be here, right? Now, I talked a lot in labs about the validity of operational definitions. So please indulge me while I revisit an old habit. The PAS asks students to rate their level of agreement with several statements. Some of those statements compare psychology to biology, chemistry, and physics. Here's an example. It is just as important for psychology students to do experiments as it is for students in biology and chemistry. Again, the lab met for 50 minutes once a week. They mostly worked on one study throughout the semester. It was a terrific in-depth approach. I mean, it was great. Students did a lit review, they generated ideas, they collected data, they even had a mock IRB and an APA report. And this is what you and I would call doing science, at least at a beginner level. But old schemas die hard. And in terms of perceptions, this is probably not what most intro level students would call doing science, especially when explicitly compared to their experiences with other sciences. I mean, there's no IRB in physics. Compared to the flasks and, sorry, my computer just blanked out on me there. Compared to flasks and spectrometers and oscilloscopes and doing a different study each week in a 3-hour lab, 50 minutes a week in Psyclab, working on the same study every week, probably doesn't feel as important. But there is some comforting news. Gurung and Stoa in 2020 found that scores on the PAS did correlate with the use of certain teaching tools in a research methods course. Not an intro lab, it was a research methods course, but reading articles, writing APA papers, group work, participating in research, and lectures, presumably on research methodology, all correlated with PAS scores. And all of these can be incorporated into a 3-hour per week intro lab. Reason 4, low cost. Yes, there is a cost in terms of teaching load and possibly teaching assistance, but that's true of every course that was ever proposed. And if the course is important to the curriculum, administrative support for restructuring is not unusual. What might help is that in terms of materials, this is a low-cost proposition. The equipment needed to run a psych lab is either cheap, easy to make, or already owned by most students. They have phones and they love to use them in class. You can do lots of cool research with just a phone or access to the internet. In cases where supplies are needed, they're generally cheap. One of the studies in Module 3 on samples and populations requires small plastic beads that you can get online for about $67. The dissection of cow eyes, most expensive study in the book. If you decide to do it, cow eyes cost on average about $1 per student, plus around $500 for dissection equipment, but that's going to last you for years. The perceptual adaptation study is a one-time cost of around $200. And each of these research options has alternatives in the book that are free or only use printed materials. But again, you don't have to use the studies in this book. You don't even have to use this book. APA has a good website. It's the Online Psychology Lab at opl.apa.org, and they have lots of ideas for research and ways of collecting data at that site. Reason 5. This is the threefer, okay? 3 reasons for the price of 1: critical thinking, confidence as scientists, and general intellectual development. I could also add career development, but there's only so much room in one box and only so much time here. So critical thinking. This is an evidence-based claim. The same study I talked about earlier, the one that compared a lab to 2 other groups, did find evidence of the lab, evidence of the effect of the lab on critical thinking. Scores on the psychological critical thinking exam actually went down in the traditional recitation group from before to after the course, but they increased in the lab group. Now this was, yes, this is a quasi-experiment with different classes, but the significant interaction agrees with the claim that the development of critical thinking is linked to the style of teaching. Another study by Thiemann et al. In 2009 reported that students in an upper level lifespan development course scored higher on the PCTE if they had taken intro with a lab component than if they had not. Although again, students were not randomly assigned to either take the lab or not. So, okay, second, by doing science, students develop confidence as scientists. If we take a kind of community of practice approach to learning, then we have to recognize that learning is a student-centered contextual process. So by having a lab, we're setting up the context. We provide learning opportunities that reveal the scientific community for what it is and what scientists do, instead of just what they produce. As students take their first steps learning to do research, they begin to imagine themselves as part of that community of practice. They're no longer just visitors dropping in on a science class to learn a thing or two, but they're actual thinkers, researchers, they're contributors. There's some evidence that undergraduate research experiences, UREs, can lead to a stronger sense of belonging for students in STEM fields, particularly for women and minorities who are underrepresented in STEM. The effects of a lab class in intro are not known, but my own experience is that confidence as a scientist can and often does begin to develop in a lab class where students engage in real research practice. I've seen it happen, and I've had upper level students come back as TAs and tell me that intro lab is where they first realized that they could be scientists. By way of supporting data, we can revisit this table from Gerung and Stoa, which also shows how confidence as a scientist correlates with the elements of a research methods class. Again, almost all of these significant correlations are things that can be done in a 3-hour per week intro lab. We don't have to wait and only do these things with psych majors. We can give so many more liberal arts majors these same opportunities. Third reason in terms of development, a widely used model of intellectual development for college students came from Perry in the 1950s. You've probably heard about it. Perry talked about the idea that freshmen start college as dualists. They see knowledge as absolute. It's right or it's wrong. And the textbook or the professor is going to tell you which one it is. They're not comfortable with ambiguity. They want answers. So a purely topics-based course with multiple choice tests and is going to tend to promote the idea that there's only one right answer to most questions, depending on how the questions are written, of course. When they learn that experts legitimately disagree on the right answers, they enter the stage of multiplicity, where, as Dutch and Norton put it, they start thinking, if nobody knows, anything goes. Then, as they learn how to test ideas and gather evidence and assess and compare the quality of evidence, they start to understand that some of the ideas are more likely to be true than others. And Perry called this intellectual relativism. Now, if many or most of our college students graduate at this stage, it's not terrible news. But of course, we'd like to get them to the last stage. That stage is called commitment, where they begin to accept uncertainty as a natural part of knowledge. Here's a quote from a qualitative study, a snippet of an interview from a student who took part in an undergraduate research experience. I've made some great realizations. I think a lot of people think science is truth, this all-encompassing certainty. And what I found out is that often what research does is just explain how something could happen or probably happens, and not necessarily how it does happen. So I think this has helped me a lot in understanding science better. Now, I know that a URE is different from a laboratory class, but I've seen firsthand that getting students to engage in evidence-based thinking, first semester in college, discussing the relative strengths of evidence and seeing what it feels like to be uncertain, even after you see your experimental results, this does move them along on the intellectual journey. And I have heard lab students over the years saying very similar things about the uncertainty of knowledge. Reason 6. Psyclab prepares students for advanced coursework. It gives them practical experience with data management and the logic of hypothesis testing and probabilistic reasoning. It gives them exposure to various research methods and how to think through the logic of research. And for some students, it gives them the confidence and the enthusiasm to pursue independent research before they graduate. And it improves writing skills, APA writing skills. Thiemann in 2009 also reported grades on an APA-style lab report in research methods class were significantly higher for students who had a lab with their intro course compared to those who didn't. And this is not just in psychology. I've had econ majors come back to me and say that what they learned about data summaries and correlations and interpreting scientific findings directly applied to their advanced courses in econ. Reason 7, research also shows increased student retention rates linked to undergraduate research experiences. Excellent reviews are out there if you just do a Google Scholar search. But I'd like to mention here that Nagda et al. Reported that in their UROP program, the Undergraduate Research Opportunities Program, which was designed to get first and second year students involved in research, they saw attrition rates nearly cut in half, from over 18% to just over 10% among Black students involved in the program compared to a control group that was not involved. So yes, this was a one-on-one mentorship program, but one of the most important goals was getting students doing research in their first and second year, which I would argue helps students feel like college really is a whole new level of learning and that they can learn at that higher level. It's not just high school part 2. It's not just gaining depth of knowledge on the subject of your choosing. It's about learning how to be a contributing member of your chosen discipline. Reason 8, resources to teach intro with a lab are available, so you really can hit the ground running. My book is, of course, one of the resources you can use. There is, as far as I'm aware, one other published book designed for teaching intro with a lab, and that is McBride and Cutting's Lab Manual for Psychological Research, and it's published by Sage. There is also, as I've mentioned, the APA's online psychology lab. Even if you're not an APA member, you can still create an account for free and you can access all their teaching resources. Now, in case you're curious, I want to give you a quick, maybe 3-minute overview of my lab book. It's a hybrid book with content and applications, including procedures and lab record worksheets. It's half textbook, half manual, kind of. It's designed for a 3-hour per week lab course in 14 weeks, but it's flexible. So if necessary, it can be used for shorter lab periods or fewer lab periods. In fact, Montana State uses it, and I believe they only meet for 8 lab sessions each semester. So let's take a quick peek at the table of contents. There are 8 modules, and each one includes essays, applications, and a glossary of new terms. Content essays are short, and I aimed to make them as standalone as possible so that it's easier to assign readings based on your specific course goals. So for example, Module 1 in separate essays introduces psychology as a science, explains myths about the scientific method, explains the philosophy of science, describes types of research, and introduces exploratory research. And then Module 2 is on descriptive research and operational definitions, including an essay on surveys and self-report data, and there's an application on that as well. And to whip through the main ideas of the other modules, there is Module 3, which is on data summaries and using descriptive data to generate, not support, new hypotheses. 4 is correlational research, 5 is experimental. 6 is quasi-experimental. Then 7th is about repeated measures and matched samples experiments. And Module 8 explains the Lego approach to more complex experimental designs. It also refutes myths about research in psychology. And one of the Module 8 applications has them doing their own research in small groups. So in our labs, this was actually a 4-week capstone experience, which was the largest chunk of the whole course. Application sections, though, generally have about 3 options that you can choose from. And each module has a detailed glossary that not only defines all the terms from the essays and applications in that module, but also provides examples and references to the essays and studies where the terms were first introduced. So you might be thinking, what if a term comes up in class or in lab or in a different module and students need a refresher or a concise explanation? How will they know which glossary to turn to? For that, they can go to Appendix D at the very back of the book, where there's a list of all the key terms with the module numbers where they're introduced. And they can use the glossary tabs over here to immediately find the term that they want. So going back to the table of contents, I also want to point out that Appendix B has the answers to all the skill check questions. Appendix C has an intro level guide to writing APA style lab reports. And I want to mention one more feature that's different from other books. I found these really useful, and I know from student feedback that they appreciate them. And that is the interactive learning objectives charts. So every module has 2 of these interactive learning objectives charts, one for essays and one for applications. Here's an example from the essay section of Module 3. Essays are listed by number in the leftmost column, and each essay has about 3 to 5 learning objectives. Now, you're likely to get students in lab with a very wide range of backgrounds. This is what happened in our labs. So some might have already done their own research when they're just coming into the class for the first time, and others might have never even heard of raw data. The goal is to teach students, the goal is to help students read what they need, not what they already know. So students read the objectives before they read the essays, and they rate how well they think they already know this stuff on a scale of 1 to 4, where 1 is like, I have no idea, and 4 is basically been there, done that. This is sort of a sneaky way of getting them to read more actively by questioning the content before they read. I told my students, though, that it's a way to individualize their reading assignments and save them time. And it is. It's only going to take them less than a minute to get a sense of how carefully they have to read each essay. So I encourage them to just skim the content that they rated as 4, make sure that they're right about what they thought they knew, and then slow down on the stuff that they rated lower, especially the 1s and the 2s. And then after reading, they can also revisit this chart and rate their understanding a second time. So students like these charts, but they're also useful for faculty. They can help you decide which essays to assign depending on your course goals, and you can collect them anonymously at the end of the module or at the end of the semester, as I did, and compare their before and after ratings to see whether your students felt like the learning objectives were being met. Now, I loved teaching my intro labs. I loved what it did for my students, and I felt like in my own small way, I was having a positive impact on science literacy. But I wanted to increase that impact. So I worked very hard to make this book as flexible and useful as I could, because I want it to be as easy as possible for other schools to teach intro with a lab. And I know that if you're thinking about it, I hope that if you're thinking about it, this book is going to make the prospect a little less scary. But remember, you can get resources in other places too. My mission is to see more intro psych students, lots more, getting practice with scientific thinking, however you can make that happen. Oh, and now we have the bonus reason. It's no great mystery. It's the benefits to teaching assistants. If you set this up as we did with junior and senior psychology and neuroscience majors as TAs, the benefits to those students are innumerable. We called our TAs PLAs, or psychology lab assistants, and this is one of our ads for a PLA position. So as advertised, they gained valuable experience, they shared their passion for science, they helped others, they became better leaders and better learners, and they got a paycheck. Now, it wasn't a large paycheck, but it helped, and they earned it. Our PLAs commented on student papers, they tutored, they helped with setting up and taking down labs, they facilitated group work, and if they chose to, they were mentored through short teaching experiences. They finished the program with visibly increased confidence and leadership skills, better understanding of general psych content, and better writing and proofreading skills, especially in APA, all of which led to higher comfort levels going into grad school, and all of which our PLAs greatly appreciated. But I'm going to steal a phrase from LeVar Burton on Reading Rainbow and say, you don't have to take my word for it. These quotes are from reports on similar intro psych TA programs. Okay, we have one that says one cohort on completing their tenure as lab instructors reported a dramatic increase in their confidence, mastery of the subject matter, and improved oral communication, writing, and teaching skills. And from Newcomb and Bagwell, overall, the teaching fellows described their experiences as the best academic experience I had, extremely helpful, an extremely rewarding experience, both academically and personally. And that sounds a lot like what I said at the beginning of this talk about my own TA experience as an undergrad. And I still remember that experience, even though it was a very, very long time ago. It's what started me on this journey, and it's what gave me this lifelong passion that brought me here to this day, giving this presentation. So with that, I want to thank you for listening to my 8 reasons, plus at least one. I was going to include a slide on challenges, but I decided to let the Q&A session be the guide for addressing any challenges that you're most worried about. At best, I might have an answer to calm your worries, and at worst, we can worry together. So if you're watching this as a recording, or we don't get to your questions, or you think of it later, here is my email, and I will do my best to respond as helpfully and quickly as I can. Thank you.
Wonderful. Congratulations, first of all, for completing the APA-IPI-SLO tongue twister.
I got that, and then I messed up. I couldn't remember whether I had covered that first graph from Gurung and Stoa. It felt like for some reason I must have blanked out while I was speaking or something. I felt like I never covered it. I don't remember. I'll be honest.
No, you did wonderful.
Thank you.
I do have some questions, and I encourage viewers to chime in as well. Keep them coming. This viewer loves the learning objectives module. She wonders, do you think students are prepared for this level of instruction as a first-year student?
Yes, that's a good question. So yeah, I mean, you're going to have some students who are going to struggle a little bit, and that's okay. I mean, if you go to your bio and your chem and your physics professors at your school and you ask them, are your students prepared for an intro lab? They're going to say, yes, some of our students come in prepared and some of them don't. And we do our best to catch everybody up. And that's basically what we had to do at Lafayette. And I think there's nothing wrong with that.
Great. In your experience, how adaptable would this module be for online or hybrid courses?
So some of the research options have already been converted by the person who is now teaching the labs at Lafayette. Some of the modules have already been converted. Some of the projects are doable online. Actually, several of them are doable online. I think you'd be able to find, if I'm not mistaken, at least one in each module that could be, massaged to make it work. So yeah, there are things, a lot of the data collection things, like I said, are online, or are basically just online things that they do anyway to collect the data. So you can have them collect the data online and all contribute the data to one set, say on Google Docs or something like that, and then have discussions online about what the results show. So yeah, a lot of these things are convertible to online projects.
Great. Have any high school teachers used this lab book?
Not that I know of. And I don't know, I don't know if that is something that they would be interested in doing. I know that high schools, it tends to be difficult to arrange labs as well there. So, but I don't know. It's an interesting question, something to think about.
This viewer works at community college and would love to see a lab, but there's usually an issue with transfer to four-year colleges and universities, surrounding credits, that sort of thing. How should they go about that?
Well, as far as if you have a lab, the thing that's not going to take away from your ability to transfer the course. If anything, it's the other way around. Having a lab will make it easier for students to transfer the credit to another course, because they're basically getting a bigger course at the community college than perhaps the school that they're going to would have offered. And I don't think that there are many schools that are going to say, no, we're not going to accept that because it came with a lab. That's like saying, no, that's too much for our school. You got better learning than you would have here. I mean, I don't think that's true, but that's basically what they would be saying. So I don't think that transferring into another school is going to be a problem if you don't have the lab.
Thanks so much. And please, if you've asked questions, let me know via the chat or Q&A if your question is answered or if I can further explain it for Carolyn. I'm doing my best to summarize them here. So will this work for large enrollment classes, like hundreds of students with very few TAs?
Well, you're probably going to have to bump up the number of TAs at the very least. We did it at Lafayette with approximately 180 intro students every semester. So there were 9 sections of lab, and they broke up into the 9 sections with 20 students per lab. That works out pretty well in terms of collecting data and having enough information to actually draw some decent conclusions here and there. So yes, I mean, I'd say if you have the teaching resources to break them out into smaller groups, yes, you can do this. And you could probably do the labs with 30 or 35 students. It's just the more students you have, the harder it's going to be to kind of get everybody consistent in their data collection and things like that. but it's doable.
Great. And another question on research ethics. First, do you cover it? And is the IRB introduced?
Yes, the IRB is introduced. It's covered in an essay in Module 5 about quasi-experimental designs. Actually, I think, sorry, in the second edition that got moved to Module 6. At any rate, it is covered in the module on quasi-experimental designs as we discuss whether certain types of research can be done as experiments and why they can't. And so there's a big thing about, what guidelines we have to follow as psychologists. So even if you opt not to do the quasi-experimental module, you can have students read that essay and learn about the things that get in the way of doing things, of experimenting on certain questions. There's also in the last module, I believe, there is a section in the application, because they're doing their own research. There's stuff about informed consent, et cetera, all the things, because we did a mock IRB. So our students did learn how to do those things, and they learned about the ethical questions that need to be answered before they can do research. So yes, it is covered.
Great. Is it typical to add 1 to 2 units for the lab part? Or is it possible to adjust a 3.0 unit course to include a lab part?
Units, by units, you mean credits? Yes, there are lots of different ways to do this. At Lafayette, every course is 1 credit, whether it has a lab with it or not. So adding the lab didn't change the credit scheme or the unit scheme, I think is what you're referring to, if I'm not mistaken. You can do it that way. That tended to raise challenges when it came to teaching load, but that's a whole other ball of wax. So yes, you can do it by adding a unit, by adding a credit. Again, I would refer to your biology, your chemistry, and your physics at your own school and see how they're handling credits with a lab, and just follow their lead, because it's really no different.
And I do have one final question. Does the lab manual come with a test bank?
It does not at this point, but if there is a demand for it, I do have questions from when we did the lab when I did the lab at Lafayette. I used to do short quizzes before each data collection, so that I knew that they knew what they were supposed to do and stuff. So yes, there are quiz questions that I could incorporate into, I believe, if I'm not mistaken, I'm not sure if Bob is online right now, but there is Kendall Hunt has a quizzing app that we could potentially load questions on to, so that students can use that, or that you could select from those questions to put into your own quizzing procedures, however you're going to do them. But yes, right now there is not a test bank, but it's a potential item for the future.
Great. And yeah, like you mentioned, don't let that be a barrier to switching. Kendall Hunt, we can work with you on designing that. So wonderful. Yeah. Great job. Want to thank everyone for joining us today. In the coming days, you'll receive access to the recording of this webinar. In addition, Dr. Buckley will share the references for the studies she's mentioned throughout the presentation. We'll get that out to you in the next few days here. I encourage you to visit kendallhunt.com/events to learn about further webinars in this area. And I hope you have a wonderful new year. Thanks so much, Carolyn.
Thank you.